Super. Welcome to the Computer Science 220 review session for the final exam. We are going to be working through some of the questions on exam number 3. Remember that the final exam covers everything from the whole semester, but that means that exam number 3 is a really good review sheet because it covers the more complicated things that we've done recently with arrays and array lists and classes. But in order to complete the problems, you also need to know about variables, expressions, input and output, if statements, and loops. So it really is pretty cumulative. The only item on the final exam that's not also on exam 3 is recursion, the most recent topic that we talked about, where it's like a fancy alternate way to make a loop by having a method that calls itself. So we're just going to work through the practice, and you can interrupt me anytime if you have questions. Try to keep it somewhat interactive. So definitely interrupt me if I'm like off on a tangent or if I say something and you're like, I have no idea what you're talking about. So the first question that was problem solving on the exam was about the baseball team, where our goal is to make an array list of strings that store the player's last name and a parallel array to store their jersey number. And then we can use a loop to enter 5 players and store all of their relevant data in the array list. We're supposed to ask each to enter the player's last name and preferred jersey number. If the jersey number is a duplicate request and somebody else on the team already has that number, then we're supposed to require the user to continue to enter numbers until they enter something that hasn't previously been requested. Then finally, after all 5 players have a jersey, then we're supposed to print out their names and their final jersey number assignments. So here's our example input and output, where it's prompting the user to enter the last name and jersey number for a player. And this is a first person, so it's not a duplicate. It's Adams, and they requested 33. Then the next player, also not a duplicate. They are Baker and requested 13. Then the third player requests the number 13, but that's a duplicate number that's already assigned to Baker. So it's going to prompt them to re-enter a jersey number. This time they entered 33. That's also taken. So they get prompted again to enter another number and they pick 10, which is good. That doesn't have a conflict. Then we're going to keep going. Asks for the first person, that's not a duplicate. The 5th person, that's a duplicate again. 33 was already assigned. Then they requested 14, that's a duplicate. And then finally requested 9. Then after everybody has their assigned jersey number, you're using a loop to go through the whole array list and print out everybody's stuff. I'm going to copy and paste the instructions in there as a comment in my program so that I don't lose them. Would it be more useful for me to type this in a Word document or in like IntelliJ? What do you think? You can put it in the chat or just say either one's fine with me. I'm going to look for the chat. IntelliJ. Excellent. All right. We're typing up the program. Let me scooch over. All right. Finally. I think we got everything in there. So step number one was to declare the two array lists. We need one to store strings, that's the player's last name, and then a second one to store jersey numbers. And you could store the jersey number as an integer or a string, whichever one sounded better to you. Because we don't have to do any kind of arithmetic with the jersey numbers, it wouldn't hurt anything in this program if you stored them as strings. I'm going to make an array list, and that always requires you to say the data type of the stuff that you're going to put into the list. We're going to put strings in the player name list. So I'm just calling the constructor for the array list class to get that set up. I think I have to import java.util for it to know about array lists. Yeah. And then I can make the jersey number list either integers or strings. I'm going to make it strings. Just thinking about it in my brain, if somebody requests jersey number like 03, I want it to be able to store the 0. And if I read it in as an integer, it won't do that. But if I store them as strings, it will store like the leading 0. But either one was fine for the exam. You could make it integers or strings, whatever sounded good to you. So that was step one, where we were creating the parallel arrays to store the jersey numbers. So next we want to use a loop to enter data for the 5 players and store it as array lists. So it tells us how many players there are. That means we can use a count controlled loop. So there's going to be 5 players. So I want to make a loop that repeats 5 times. And I want to prompt the user to enter the name and jersey number. And then I'm going to read both of those in. um, all right, so then I gotta make my scanner in here. Awesome. And if everything was just like, if I didn't have to worry about the duplicates, then after I read in the name and jersey number, I could simply add them to the array list by calling the add method. So I'll add the name to the player's name list and then add the jersey number to the jersey number list. So I'm skipping over the part about the duplicates right now. And then I'm going to move on to this last part that I could use to test out my program. Once everybody entered their jersey, print all the names and the jersey number assignments. That'll be a second loop. And I can reuse I if I want to, or I can make a different variable. Either one's fine. And I want to print out the player name at position I. So I'm going to call the get method from the array list. And then I'm going to put a space in between them. And then the jersey number for that same person. So that's the bulk of the program. Again, the only thing that's not in there so far is the finding the duplicates. I always like to stop and test stuff out before I get too far. What was the data is supposed to look like again. So Adams, 33, Baker, 13, Cooper, 13, Davis, 14, Edwards, 33. So that assigned all the values. Again, the only thing it didn't do was correct for the duplicates. It let Cooper and Baker both be number 13 and Edwards and Adams both be number 33 instead of prompting for new numbers. So to fix that, we can figure out that it's a duplicate number after they've entered the jersey and before we add it to the list. So in here, this is where we're going to look for duplicates. And we can tell if something's a duplicate by checking to see if the array list contains that value. And the array list class already has that method contains in it that returns true or false, whether or not that value is already in the list. So we could do something like Boolean is in list. And I want to look at the jersey list to see, does it contain the requested jersey number? And then if it does, I want to ask the user to enter a new jersey number. So if is in list is true, that means it's already assigned to some other player. It's already in my array list. And then I want to prompt them to enter a new jersey number. And then read in the new number. So let's try that out. My Zoom screen is covering up where I need my mouse to be. All right, so I'm gonna do Cooper 13 and then Davis wait, I skipped over one. Adams 33. And then Baker 13. So that was a duplicate, so it's gonna ask me to enter a second number for that one. So if I say 10, that's fine, because that wasn't a duplicate, so now it's moving on. And now I'm going to do Davis 13, and then Edwards 14, and that's a duplicate. And then if I ask it for a new number and I pick something that's already in there, it's still going to allow me to assign that value, the duplicate value, to that person. So this is correcting for if they enter a taken jersey number once, but doesn't allow you to repeatedly continue to ask for the new jersey number until you run out of possibilities. So we need to not just have a single if statement in here, we need to make it a loop that says as long as the number is in the jersey list, then keep looking for or keep requesting a new value. So I'm going to check to see if the value is in the array list. If it is, then this while loop condition will be true, and I'll prompt the user to enter a new number, read it in, and then I'll want to check again, is that new number in the list? If it's also in the list, I'm going to repeat the process, asking for a new number, letting them enter a jersey, and then checking to see if it's in the list. And this loop will only stop once they enter something that isn't already in the array list. Once it's not in the array list, then we know we have a unique jersey number for that player, and we can add both items to the array list. Let me test it one more time. with Adams and 33, Baker and 13, Cooper and 13. That's a duplicate. So it's telling me to enter a new number. I say 33. It's like, hey, that's also already taken. And I can do that as many times as I need to. I can keep entering stuff that's in the list, and it'll continue to ask me to repeat as many times as needed until I pick something that's not in the list. Then I'll move on with other players. And Edward's 33, that's a duplicate, so it's asking me to enter a new number. So I could do 14, that's also taken, 13, that's also taken, 10, that's also taken. It's only when I enter something that's new that it moves on with the rest of the program. So this program was testing out a couple different things. Did you know how to declare an array list? And so if that's syntax that's unfamiliar to you, if that's not top of mind, then definitely put that on your note card. Actually, you can bring a whole sheet of paper with stuff on both sides of it to the final exam. So put that on there. Then it was testing to make sure that you knew about the methods that are part of the array list class. So those include contains, add, and get. Um, those were three of the methods that we looked at with the array list. There were some other methods that we learned about as well. They're all in the class notes from the day that we talked about array lists. The other methods included remove. There was also a size to tell you how many things were in the array list. In this program, we just knew there was 5, so we didn't need to use that method, but you could in other programs. And there was also an index of that tells you the position of an item in the array list. So again, I'm not expecting you to know everything that's in the array list class, but look at the class notes. It has a list of about 10 or 12 different methods that you should know how to use. And those are the things that I'd ask you to access or utilize in a solution related to array lists. I'm going to stop for a minute and pause our recording in case you have questions again. All right, we are back and talking about question number 4 on the exam. Let me share my screen again so we can read through the question. So this one, we were monitoring rainfall, and we have 4 different regions that we're keeping track of, and we're keeping or making a record of the rainfall amount for 10 weeks through the monitoring period. And it gives you a little example of what the data might look like. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 10 weeks for a single region. So the row 0 in here is like the north region, and then the row 1 is the south, row 2 is the east, and then row 3 is the west. And it's asking us to calculate the average rainfall for different portions of this data. So it's saying we're going to make a method that finds the average across the whole thing, all the regions, and then one that just does a specific week. So a specific week would be a column in the data, since each one of these columns represents one of the weeks in the monitored time period. And then finally, the regional average, that'll be the average across one row in the table. And it gives us this existing main program where it already has some constants set up to represent the number of regions, the 4 rows in the table, and the 10 weeks, the columns in the table. It already has a 2-dimensional array defined in there, so we're making a table of data that visually is going to look like the table up at the top. It already has the nested loop in there that reads in all of the data, so the user enters it and it stores it again in that same format that's shown there. And then it's calling the various methods to calculate the averages. So it's calling the method that does not yet exist, but we're going to write to calculate the overall average across the whole table and then print that out. Then it has a part where it asks the user for a week, so a specific column number, and then it calculates the average just for that week, so just within the column. And then finally asks the user for a region number, and then calculates the average across that row in the table. So our goal is to write those three missing methods: calculate overall average, calculate weekly average, and calculate regional average. And we want our stuff to match with how the methods were called. So that gives us a clue about how to write the parameters and the return types in our method when we look at how the method's called in the main program. So again, there's like just big giant space for you to write those three methods in there. I'm going to copy and paste into my program. Oh, it's already in my program. All right, so I copied and pasted the part that was provided for us. Again, that's what we just walked through. And you can see the red pieces. That's what we still need to write the implementation for all of those methods. So I'm going to start with the first one first, the calculate overall average. That's calculating the average of all 40 values in the table. And we can tell by the way the method's called that it has to be named calc overall average. So it's going to be my method name. And I can tell its return value is supposed to be a double because I'm storing the return value as a double. And then I can tell that the parameter for this method is supposed to be the same data type as rainfall. And if I look up, rainfall is the two-dimensional array of doubles. So I want to use all of that data while I'm setting up calculate average. So I said the return type is going to be a double. And then the parameter is going to be a two-dimensional array of doubles. And the goal of this one is to find the average across all 40 values. So that means we'll have to traverse all of the rows and all of the columns that are in the table. And we could use this for loop that is included for reading in the data. We're going to use the same kind of format when we're trying to calculate the average. We're just not going to read data in. And are going to calculate the average instead. So I'm going to need a variable to create the sum of all the different values. Oh, and I called it table in my method. So again, to sum up all 40 values, you need to go across all the rows and across all the columns. So visually, we got this table of data, and we're going to say, starting with row 0, column 0, I'm going to add this value to sum. Then I want to stay in the same row and add the next column's value to the sum. Stay in the next same row, add the next column's value to the sum, and so forth, moving across the whole row. Then once I get to the end of the row, I'm going to go back to the outside loop where the value of the row gets updated, and then repeat the same process. We're going to be adding all 40 values to the sum. And then once I get to the end of that, that'll be outside the outer loop. Then to calculate the average, I want to take the sum and divide it by 40. That's the number of things that are in the table. And then that's the value that I'm going to return back. That's the average. And if you didn't know how many rows and columns there were, like if those weren't constants, you could also say regions times weeks. Because the number of regions is 4 and the number of weeks is 10. So multiplying those two things together is what's going to tell you how many total things you added up. Again, either of those was fine. for the exam if you said sum divided by regions times weeks or just sum divided by 40. Those are both good. Let's do the next one. The next one is calculating the weekly average. So in this one, they're going to tell us a week number, a column number, and we're going to sum up just that one column and then calculate the average. And again, we kind of have to like read the method call to figure out what are the expected return type and parameters. So for this one, the return type's also a double. Tell because we're storing the answer as a double. And then we need the two-dimensional array as the first argument and a integer value, the week number as the second argument. I'm going to copy the method name. So public static double, that's the visibility and then also the return type. And then we want this one to take a two-dimensional array and an integer that represents the column that we're going to sum up across. Public. Just like before, we're going to need something that keeps track of the sum of all the values. For this one, the column is going to stay the same, so we're only going to have one loop in here, something that goes across all the different rows. So the rows are the regions. That's what we're going to vary. And then each time we get to a new region, we're going to add its column value onto the sum. So table at row, and then column is going to be constant. It doesn't change value. It's just whatever they passed in. And then after we've added everything up, we can calculate the average. That's going to be the sum divided by the number of regions. However many times you repeated, that's what you want to divide by at the bottom. So in this case, we added up 4 possible values because there's 4 regions. So at the end, we want to divide by 4. And then we're going to return that value. And that's it for the second one. And then the last one is calculate the regional average. So they're going to tell us a row that we want to sum up across, and we're going to add the 10 values in that row to get the average. This one also has a double as the return value. This one takes the region, the integer. Oh, this is where I had a typo on the exam. It's supposed to be region number. But I think nobody told me that until section number 2. So if you were in section number 1, you might not have caught that nuance. But so it's supposed to be the number of the region that they wanted to sum up for, and then the table as the second argument. We need to make our method definition match the same style. The regional average, and then this time I want it to pass in the row, and then second it's passing in the table. Again, that's just because I knew that because the parameters were listed in that order where it was the integer first and then the table second. And then approach down here is exactly the same. We're going to have a sum. It's going to start at 0. We're going to make a loop that goes across all the different columns. And in there, we're going to add on the table at row column. Where column is the part that's going to change. Row just stays the same. It's whatever they typed in as their argument. And then at the end, we're going to divide it by the number of columns and return the average. And down here, I had it. So I was writing our three methods. Um, they all had a really similar algorithm. So no matter what, you needed a sum variable. You needed some kind of loop to add up all the possible values that you cared about, and then something where you divided by the right number of items and then returned the result. If you want to add up everything across the whole table, then you need a nested loop. If you're just adding a single column, then you just need one loop. And if you're adding just a single row, you just need one loop. This has a lot of data in it, so we're going to try my patience on entering all of it. Um, and 3.2, 1.5, 0.8, 2.1, 4.3, 1.2, 0.5. I'm very tempted to copy it from the exam sheet. But I think that if I do that, it will have some sort of word formatting in it that'll mess it up. Awesome. So it's telling me my overall average was 2 point something, just eyeballing it. That looks possible. There's definitely some things on there that are bigger than two and some things that are smaller than two, but everything kind of looks like it's between 0 and 5. Um, so I'm buying that it could possibly be 2.0. I'm going to do week number 0. That's the first column, the 3.2, 2.8, 1.5, 4.1. So I'm thinking the average is going to be somewhere in the like 2 point something, 3 point something. Yeah, 2.9. That sounds right to me. Again, just eyeballing it. And then let's do the first column. Again, looking at it, I'm guessing it's like 2 point something. So if we do region number 0, it's going to add across the top row. And again, that looks possible to me. I was guessing it was going to be somewhere around 2. And of course, you could use your calculator to noodle it out, double check your work. Let me stop sharing again, and I'll pause for questions. All right, so now we are looking at the fifth question on the exam. Let me share my screen again. And this one was testing about your knowledge of object-oriented programming. So this was similar to the programming practice assignments where you made a movie class. So the first part says you're given the following description and tasked with creating a class. So it's going to be like the movie class to meet the specifications. And it says we're designing a book class that's going to have a title, a genre, which has to be mystery, sci-fi, or fantasy, a total number of pages, and a current page number. Somebody else is writing the main program that's going to use the book class to track reading progress for a library app. And she has expectations for your class. She needs to be able to do all these different things. That means this part down here, the bulleted list, is describing the different methods that should be part of your book class. So when you're thinking about the data fields, it's going to be the things that are described as like the book can be modeled using these pieces of data. That means these are the data fields. And then this bulleted list down here is the list of methods that should be part of the class. It says we need to be able to create a new book variable. That's going to be the constructor. We have to be able to retrieve a few of the data field values. So those are going to be getter methods. And then we need to be able to update the reading progress by changing the current page number. So that'll be setting the page number. So that'll be like a setter method. And then it says you only have to write the parts that are described here. In other words, I didn't take off points if you added in extra methods that weren't described here, but you didn't need to waste your time doing that. You only had to do the ones that were described here. If there were like extra setter methods and things like that that came to mind, you weren't responsible for writing all of those things, just because that would be really long. All right, so we want to start writing the book class. Have my Java file open here. And so we would have this in a separate file. Make a new Java class for book. And again, what we want to put in here are two pieces, the data fields and the method implementations. Where the data fields are the different pieces of data that were described. So the title, genre, total number of pages, and current page. Um, and using best practices, we'd want to make all of our data private. If it ever says something in the description about making a class and it says like use best practices for visibility, it just means make all the data fields private and all the methods public. All right, so I'm going to copy in the description for some of these because they're kind of long. So this first bullet is the constructor for the class. Um, We're going to make a new book class. We're going to store in the data about those four data fields. Awesome. And it says books always have a known title, total page, and genre when they're created. And that's trying to imply like you don't need to make a default constructor. You only had to make the non-default constructor, one where you already knew these three pieces of data, the title, total pages, and genre. So making my constructor, I want to use public because it's a method. And then my method name for the constructor has to match the class name. So it'll be book. And then I'm saying they always know the title, total pages, and genre. So title, total pages, and genre would be the parameters for that one. Those are all known as you're getting started. And then it tells us down at the bottom, the current page is always set to 1. So we want to initialize each of these data fields, title, genre, total page, current page, using the values that get passed in as parameters. And then current page always gets set to 1. And then it also tells us some fancy stuff in here where it says, make sure that the book's genre is one of the 3 options. If it's not, generate an exception. So in here, pull that one out because it's like fancy and special. Before we set up the genre, we want to check to see whether the genre is one of those 3 values. So G is sci-fi, or G is mystery, or G is fantasy. Oh, I was like, where did I miss a curly or a double quotes? There you go. So if it's a valid genre, if it's one of those three allowed values, then I'm going to use that to initialize my genre data field. And then otherwise, I want to throw a new exception. And now my code is freaking out because I have to indicate that this method has the potential to throw an exception. So again, we were writing a non-default constructor. We could tell it was non-default because it said, hey, you're always going to know some of this information ahead of time. You're never making a book where you don't know the title, the number of pages, and the genre. That's all known when you're like adding it to the database of books. And that you're always going to set the current page number to 1. And then the extra fancy part in there was checking to make sure that the genre was something allowed. And if it wasn't, then we were generating a new exception. And then our main program would handle that exception however it wanted to. It could either specify it, and if the exception gets thrown, it just ends the program, or it could use a try catch and then ask them to like re-enter their data or something like that. Awesome. So that was the first bullet there. The next three are all going to be really similar. They were all getter methods. So we want to write a getter method to retrieve the title. So the title is a string. And I get the title. And you're just returning and then the name of one of the data fields. Getting the title. Getting the genre. And getting the current page number. I'm like, could you have written one for the get the total number of pages? Sure, absolutely, we could have done that. I just like didn't want to make you write every method on the planet because it just takes a long time on the exam. So those were the middle three bullets there. And then the last one was a setter method, something that was updating the number of pages. So it's going to advance the current page number to a specified value to represent reading progress. The current page number always has to be a positive value and can never exceed the number of pages in the book. Additionally, the current page number can only increase over time. So if the method gets called with a value that would violate these ideas, then don't change the current page number. Just leave it alone. Return true if you updated the current page value and false if you didn't. So this is going to be a setter method that returns a Boolean value, either true or false. So we're going to set the current page to a new value. Say like, I've read more in my book. And I should update the value if the current page number is bigger than the existing, or if the new page number is bigger than the current page number, then I should update it. I'm going to set current page, go to the new page. And then I also need my Boolean in here. So if the new page is bigger than the current page, so like if I was on page 5 and now I'm on page 20, And 20 is the new page number, then 20 is going to be bigger than 5. So I should set the current page to be 20. And then I did update it. So the result's going to be true. And then I also need to check my current page shouldn't exceed the number of pages in the book. So I also want to make sure that new page is less than or equal to the total pages. Because if there's only 100 pages in the book and somebody tells me now I'm on page 1,000, I shouldn't let them update the current page number to be something that exceeds the end of the book. So I'm going to check the lower bound on that has to be at least, or it has to be larger than the new page, at least one page in advance from the current page. And then the new page also has to be less than the number of pages in the book. And then at the end, I'm going to return result. So if it wasn't a valid page, the result will still just be false and we'll return that. Otherwise, it'll be true. So that was all the methods for the part A. I'm going to delete out my comments because they just make it long. So we ended up with those 5 method implementations, 1 for each bullet. And when you're reading a problem description like that, it's always going to be the case that each of these bullets represents one method that you're supposed to write. So it kind of gives you a guideline of like, this is how many methods you should have in your final coding solution. Again, it was totally possible that you could write more methods in there. You could have put extra setter methods, extra getter methods, another constructor, you know, the toString, the equals method, any of that could have been fair game for the problem. But I always try to limit it so you only have a couple things to write. So even though all of those things are possible and should be in a final solution for an exam situation, you'll only have to write part of those. This problem kind of goes together with part B, where in this part, we're writing the main program. We want it to ask the user how many books they're going to check out, make an array list of that number of books, and then ask the user to enter the titles and genres, add the books to the array list, use the stuff that you wrote in the previous problem. I feel like this is not the most up-to-date version of the exam. I feel like there was something else in there that we were supposed to do. All right, well, I'll do this and then I'll ask you guys if you know what we were supposed to add in there as extra stuff. I think I added an extra part to that problem before I handed it out. All right, so first we're going to ask the user how many books they want to enter. And then reading that in. And then we wanted to make an array list with that number of books. So we're going to use book as our data type. We're making an array list using our data type book that we just defined. And then you could be fancy and put num books in here as the initial size of the array list. Remember, array list has a couple different constructors in it. It has one that doesn't take a size, and it sets up the array list to have 10 things in it initially, and then it'll grow and shrink as you add and remove things. It also has the capability of letting you say how many items are in the list and then setting up the array list to be that size. It still will grow and shrink over time as you add stuff. So for this problem, it was not important to me that you put the num books in there. If you just use the regular default constructor for array list, that was fine. And then you need a loop to repeat for each of the books. Whoops, there we go. Where you were going to prompt the user to enter the title and genre. I forgot to tell you to enter the total pages, but you should definitely have done that too. Enter title, genre, and total pages. And then you needed to read those into local variables. Whoops. So reading in the title, genre, and the total pages. We'll call that TP. Then once you had those three separate pieces of data, that's where you want to encapsulate them together and make your book object out of them. So we're going to call our book constructor. It takes the title, then the total pages, then the genre. I'm going to say book equals new book, title, total pages, genre, so that I match the order. Oh, and it's telling me, hey, your book class generates an exception. So that means we gotta put the throws exception up here. Or we could add a try catch block. Either one would be fine. And I didn't care which one you did on the exam. And then finally, once we have that bundle of book stuff, then we can put it in our array list where each item in the array list is a book. So I can call book list dot add to add B to that book list. And then I feel like there was something else. There was like a loop where you were like looking to see how many books or count how many books. That's what it was. Was that like a separate part of this question? Maybe. It's like not a separate part of this question on here, but I'm remembering this now. So then you also had to add in something where you made a user defined method that counted how many books were in progress. So it's going to be something separate from the main method. Something down here where you say, count the books in progress, and you pass in the array list of books. So in here, you needed a loop and a counter. To iterate through for each book. So for each book, you wanted to see is the current pages for this book bigger than 1. So if the list dot get I, that means give me one book, the ith book. Oops. And then once I have the ith book, I want to look at its page number, its current pages. So I want to get the current page. And if that value was bigger than 1, that means that somebody started that book. So we should count that as one of the books that was started. And then at the end, we're going to return count. And then it said add code to your main program to test out this method. So you just had to do something where you said, call the count books in progress and pass in my book list. So any valid call to the method was cool for testing it out. So again, this was testing if you knew how to make an array list of objects, similar to what we did in the programming practice week 11 with the list of movies. And then also, you probably did something really similar in your project number 5, where you made an array list of something, and then you had to use a loop or something to read in some data, either from a file or from the user, individual pieces of data, and then group them all together by calling your constructor. And then once you had the group solidified, then you could add it to your array list. And then this was, again, just checking to make sure that you knew about the different methods that are part of the array list class, mostly to know that you had to use the get method to access a specific array index in the list. And then you had to call your methods that were part of the book class to get the individual piece of data out of that bundle to do something with it. In this case, you were counting how many of them had a value bigger than 1. Let me pause there for questions. Right, so we're going to look at the last code-oriented problem on the exam. That was the tracing problem, where you were looking at some provided code that included some method calls, and your goal was to record the output from the program. So the various print statements output kind of in the order that they execute. So I was testing to see if you understood how the program's control moves between the main program and the methods themselves. Every time there was a method call, the program's going to go to that method and print out some additional information. So I loaded this up in in IntelliJ, and I set a breakpoint to the first kind of spot where it is going to do something interesting and print some stuff out. And we can kind of predict what's going to happen before it happens. Just moving through the program with the debugger. I think it's ready. Oh, there it goes. All right. So getting started in the program, we're keeping track of a couple different variables. I always like to keep track of that as like memory that I'm recording. So I got the original price and the discount rate. And then I'm also going to keep track of the output down here. So as I'm entering or executing the program, it's going to initialize those 2 data values first, that recorded. And then next, it's going to print this output statement. So it's going to print before and then the value of the original price. And the value of original price is 100. So we'll print that out. Then we're calling the update method update 1 using the original price and the discount rate as my 2 parameters. And remember that each method has its own scope. So this method memory that I recorded earlier is really just the values that are in main. So as I'm getting ready to set up the memory for update 2, it's pressing in the 100 and then the 0.2. So the value of price is going to get the value from that first argument, the 100. And then the value for the parameter discount is going to get the value from the second argument, 0.2. And then once it has all of that set up, then that's when it transfers control to the body of the method and starts executing that. So we're on this part where it's calling the method, just got all the data set up, and now we're executing the body of the method. First, it's telling us to calculate a new price by taking the current price, multiplying it by the discount, and then subtracting that value from the original price. So that's going to be 100 minus 20. And so the new value of price is going to be 80, which is the result of that mathematical calculation. And then next, it's going to print out inside 1 and then print the value of price, which is 80. So one thing that I think a lot of people got confused about is they were just writing down all of the output from the main program, and then at the bottom, we're writing the values from the method. But they're actually going to be interleaved. Every time you call the method, it's going to print the stuff from inside that method. And then once the method completes, everything about the memory for that method disappears and you return back to the main program. And we're like wrapping up our method down here in the debugger. And if we go over to the console, you can see it already printed both things. It printed the before message and then the inside message while we were inside the update one method. So next it's going to print after and then the original price. And the original price, it's still 100. Then next it's going to set up this array scores. It's my array of stuff. And then it's going to print out before and then the value of score at position 1. So 85 is at position 0, the 90 is at position 1, and then the 78 is at position 2. So it's just going to print before and then the 90, because that's the part at position 1. And now it's going to get ready to call update 2. So we're going to need to keep track of the memory there. And it's passing in the scores, so that whole array. And remember, when it passes in a array or any kind of reference type, it doesn't make a copy of it. It passes a reference to the original memory location. So it's passing kind of like the memory location associated with that whole array. And if we change anything about that array as the method's executing, it's going to change the original stuff that was in main. So it's passing in that array, and then it's also passing in the value 95 as the second argument. So then we got to scroll down to update 2 to see how all of that gets transferred in. So here, anytime we refer to numbers, it's going to point back to that original array scores. And the new value, that's a primitive, so it's just passing in a copy of the 95. And once all the data is set up there, then it starts executing the statements in here. The first thing it says to do is change numbers at position 1 to be the new value. So numbers points back to the scores, and the value at position 1 is this middle one. It's updating that so it's 95. And then it's going to print out inside 2. And then the value of numbers at position 1. Again, anytime it references numbers, it's pointing back to the original array scores, and the value there at position 1 is the 95. And then that method is finished, so its scope goes away and we return back to the calling spot. And again, at that point, it's going to have printed the inside to message before it goes back. And then next, it's going to do the print statement that's after the method. So it prints after call, and then prints out the value of scores at position 1. That's the 95. And then next, it's going to print out value and then the information at position 2 in the array. That's the 78. Then next, it's going to call update 1 and pass in the double price 50 and the discount 10%. So now it's going to go down to the update 1. In there, it's going to call the first value price. It's the 50. And then the second value is discount. That's the 10. And then it's going to make the calculation. So it's going to take the 50 and then minus 50 times 10%. That's 5. So 50 minus 5 is 45. Store my new value there, 45. And then it's going to print out inside 1 and the 45. Let me catch up on my debugger. So it's calculating the 45 and then printing it out in the console. And then back in the main program, it's going to print price is. Now at that point, the memory for update 1 has gone away because the method's complete. I'm going to print out price is, and then the original price is still 100. It didn't change at all. It wasn't connected up to that method in any way. And then finally, we're going to get ready to execute update 2. And in this case, we're passing in scores. And then the new value, which is 88. So when we do that, it's going to look at the first argument and match that up with numbers. So numbers is my new name that I'm using to refer to scores. Anytime I reference numbers in this method, it's going to go back to that original memory location for the scores array. And the new value is my argument, the second argument, the 88. So in here, it's going to change the value of numbers at position 1 to be the new value. So when it sees numbers at position 1, it thinks scores at position 1. That's the middle number, the 95. And it's going to set that to be 88. And then that's right there. And then we want to print out inside 2 and then that number 88. And then that's the end of the method. We're gonna bounce back to the main program where it was called, and all that memory about the local method goes away. And now we're printing the final line, final, and then the value of scores at position 1, that's the 88. So again, this was testing to see if you understood the order of the instructions that would execute as you were calling methods. It always starts in the main program and executes through. Anytime you see a method call, it's going to match up the argument values with the parameter values in the method, and then jump and execute all of that method code, possibly printing stuff out, and then return back to the main program when it's finished. When things are reference types like an array, then it passes in the memory address of that reference. So it'll change the original values. Anything that's just a primitive type, like a double or a character or a Boolean or an integer, it passes in a copy, and so it doesn't change the original for those. Let me pause for more. So that wraps up our review session for the final exam. Don't forget, if you have any questions as you're studying, don't hesitate to email over the weekend. I hope you guys have a happy snow day, and I'll see you next week on Wednesday.